Alright, let's talk about something truly mind-blowing. Imagine a robot that looks like a person, standing there one moment, and then a split second later, it's flying. I mean actually flying through the air with jet engines. This isn't a scene from a Hollywood blockbuster, this is real science, and it happened. The robot's name is Iron Cub 3, and it has officially become the world's first flying humanoid robot. This event marks a massive step forward in the world of robotics. We've seen robots that can walk, run, and even do backflips, but giving one the power of flight is a whole different ballgame. It's a moment that will go down in the history books of engineering and innovation. The first flight was an incredible sight to behold. It wasn't a long journey across a city, but a controlled, stable liftoff in a laboratory setting. For a few powerful seconds, Iron Cub 3 hovered above the ground, its jet engines roaring with controlled force. For the team of scientists at the Italian Institute of Technology who built it, this was the culmination of years of hard work, countless calculations, and probably a few spectacular failures along the way. That's how science works after all. You try, you fail, you learn, and you try again. This successful flight proved that their wild idea was not just possible, but was now a reality. They had given a machine a human form and the freedom of the skies. Watching the footage, you can't help but feel a sense of wonder. It's like seeing a prototype from your favorite sci-fi movie come to life right before your eyes. The robot, with its sleek metal frame, isn't just a drone with arms and legs attached. It's a complex system where every part has to work in perfect harmony. The successful flight represents a monumental achievement in engineering, pushing the boundaries of what we thought machines were capable of. It's one of those I was there when moments for the robotics community. A true game changer that opens up a universe of new possibilities for how robots can assist humanity in the future. This breakthrough is so much more than just a cool demonstration. It's a proof of concept that could revolutionize how we approach complex problems in dangerous environments. Think about it. A robot that can walk over rubble and then fly over an obstacle that is too big to climb. This first flight is the starting pistol for a new race in robotics. The race to create machines that can go where humans can't, do things humans can't, and help us in ways we are only just beginning to imagine. The age of flying humanoid robots has officially begun, and I, for one, cannot wait to see what they build next. So, how do you actually build a flying robot that looks like a person? Let's get into the awesome design of Iron Cub 3. The robot is based on an existing humanoid robot called iCub, which is already pretty advanced. But the team gave it a major upgrade. The most noticeable and frankly coolest additions are the 4 jet engines. 2 are mounted on its back like a jetpack, and there's one on each hand pointing downwards. This setup isn't just for looks, it's a brilliant piece of engineering for controlling flight. The engines on the hands allow the robot to make very fine adjustments, steering and balancing itself in the air with incredible precision. It's like having thrusters you can aim. The body of Iron Cub 3 is designed to be both strong and lightweight. You can't have a flying machine that's too heavy, or it will never get off the ground. The engineers use materials like aluminum alloys and special plastics to keep the weight down without sacrificing strength. The robot stands about 1.25 meters tall, making it a compact powerhouse. Every wire, every motor, and every sensor is carefully placed to distribute the weight evenly. This balance is crucial. If one side were even slightly heavier, the robot would immediately spin out of control the moment it tried to lift off. Building Iron Cub 3 was a masterclass in compromise and precision engineering. One of the biggest challenges was managing the incredible heat produced by the jet engines. These aren't toy propellers, they are miniature turbines that get extremely hot very fast. To protect the robot's delicate electronics and internal parts, the team had to design a special heat-resistant suit. They covered its legs and body in a material that could withstand the high temperatures. This is a classic engineering problem. Your power source is also your biggest danger. It's like building a race car where you have to make sure the engine doesn't melt the chassis. The solution was both practical and gave the robot its signature iron look. The human-like form of Iron Cub 3 is also incredibly important. It's not just to make it look cool. A humanoid design means the robot can potentially use tools made for humans, open doors, or navigate spaces designed for people. After it lands, it can walk around like any other humanoid robot. This combination of walking and flying is what makes it so special. It can move through a building on foot, and then, if it reaches a collapsed staircase or a huge gap, it can simply fly to the other side. This dual-mode mobility makes Iron Cub 3 one of the most versatile and potentially useful robots ever created. Now, strapping jet engines to a robot is one thing. Making it fly without crashing is a whole other level of difficulty. This is where the real magic happens, and that magic is artificial intelligence. The Iron Cub 3 has a sophisticated AI brain that acts as its flight controller. This AI system has to process a massive amount of information in real time. It takes data from sensors all over the robot's body, sensors that measure its tilt, speed and altitude, and uses that information to constantly adjust the thrust from the 4 jet engines. It makes thousands of tiny calculations every single second to keep the robot perfectly stable. One of the main problems the researchers faced was balance. Humans are naturally good at balancing, but for a robot, it's incredibly complex. Imagine trying to balance on a beach ball while juggling flaming torches. That's kind of what Iron Cub 3 has to do in the air. The AI was trained through countless simulations before the actual flight. In these virtual tests, the AI learned what would happen if it pushed one engine a little harder or softer. It learned how to react to tiny gusts of wind or slight shifts in its own weight. This trial and error process in a safe, simulated environment was absolutely essential for success in the real world. The AI doesn't just manage the big movements, it handles the incredibly fine ones too. The jets on the robot's hands are key to this. The AI can independently control the power of each of the 4 engines. If the robot starts to tilt to the left, the AI instantly increases the power of the right-hand jet and decreases the left one to push it back upright. This is happening constantly, faster than a human pilot could ever react. This is what makes the flight look so smooth and controlled. It's a beautiful, high-speed dance between sensors, software, and raw power, all choreographed by the artificial intelligence. Beyond just staying upright, the AI also has to manage the robot's flight path. The scientists can give the robot a command, like hover at this height or move forward 2 meters. The AI then has to translate that high-level command into the precise engine thrust needed to execute the maneuver safely and accurately. This is a huge leap from simply remote controlling a drone. The robot has a degree of autonomy, making its own low-level decisions to achieve a goal. This intelligence is what separates Iron Cub 3 from being just a flying machine and makes it a true robotic aviator. So, we have a flying humanoid robot. That's amazing, but what do we do with it? The potential applications are straight out of a superhero story, and they could change the world. The most immediate and important use for a robot like Iron Cub 3 is in disaster response. Imagine an earthquake has caused a building to collapse. It's too dangerous for human rescuers to enter. You could send in Iron Cub 3. It could walk through the stable parts of the building, and when it reaches a chasm or a pile of impassable rubble, it could simply fly over it to continue the search for survivors. This technology could also be a game changer for industrial inspection and maintenance. Think about inspecting a massive bridge, a towering wind turbine, or the outside of a skyscraper. Currently, these jobs are dangerous, time-consuming, and require highly skilled people working at great heights. A flying humanoid robot could fly up to the inspection point, land on a narrow ledge, and then use its hands to perform complex tasks, like tightening a bolt or using a sensor to check for cracks. This would make these essential jobs safer and more efficient, saving both time and, more importantly, human lives. Of course, we are still at the very beginning of this journey. The first flight was short, and the robot is still a research prototype. There are many more challenges to solve before we see armies of Iron Cub 3S flying to the rescue. Engineers will need to improve battery life or fuel efficiency to allow for longer flight times. They will also need to make the robots even more robust and capable of handling unpredictable weather conditions. But every great technological revolution starts with a first step, and the flight of Iron Cub 3 was a huge, jet-powered leap. It has shown us what is possible. Ultimately, the flight of Iron Cub 3 is a powerful symbol of human ingenuity. It reminds us that the only limits are our own imagination. What was once confined to the pages of science fiction is now being assembled in laboratories. This isn't just about building a better robot. It's about creating new tools that can extend our own abilities and help us build a safer, better future. The sky is no longer the limit for robots, it's just the beginning. The flying humanoid robot has arrived, and it's here to show us a future where we can solve problems we once thought were impossible.